Alright, welcome to the third video, lesson 2, multiplying and dividing rationals. We're going to be dividing the rational expressions in this one. So remember that when we divide fractions, if I had 1/4 divided by 3/8, something like that, I would rewrite it as multiplication. Keep the first fraction the same, change to multiply, and reciprocate this. You're multiplying by the reciprocal. And then, of course, you can cancel out pieces. Actually, if I divide by 4, I get a 2 up here, and so this ends up reducing to 2/3. So we're going to change this. This is why multiplying and dividing rational expressions go so well together. We're just going to change division to multiplication by rewriting, by pretty much multiplying by the reciprocal of this, flip this, and then see what cancels. Just like in the last two videos, we still have to write our restrictions, but other than that, we don't have anything to worry about. Now, the restrictions part is a little bit different because we do have a denominator here, and we have a denominator here, but when I reciprocate this, I also end up turning that into a denominator. So I actually pick up a few more restrictions than in my multiplying piece. Alright, but before we do this, let's just go ahead and rewrite. So I'm going to keep the first fraction the same. Change to multiply and then reciprocate. I love dividing fractions. I know you think I'm weird, but I love it. Alright, so let's state our restrictions. Alright, so here, we might need a little bit of work, but here, y, actually this one's going to be easiest, y is not allowed to be 6. Here I would have to subtract 19 and divide by 3, so it's not allowed to be negative 19/3. And if you want to know what I just did, I just solved this for y in my head by subtracting 19 and dividing by 3. I got this value. Alright, and then for this one, subtract 7, divide by 5, so we're not allowed to have negative 7/5. So sometimes these answers are not these restrictions, they're not very pretty, but we still have to state them. Alright, we're looking for things that we can factor, not factorable, 19's prime, not factorable. Hey, this is going to be easy. So I just got to look to see what cancels, and it looks like I've got my 5y's plus 7 there, and so my final answer is y minus 6 over 3y plus 19. Remember, I can't cancel pieces that are being added or subtracted together. So that's the answer, and we've got all our restrictions. We're good to go. That's example 5. Alright, let's look at 6. Now 6, I had a little error when I was writing. It was originally these had J's. I wanted W's, so I accidentally wrote this as a J and then tried to change it into a W. So that's what's going on there. Alright, so what I like to do when I do these is I like to try to combine steps because right now I don't have a lot of room. So what I do is when I keep this the same, I'm going to go ahead and write it in factored form. I'm going to change this to multiply. I'm going to flip these. I know that this is going to be moved to the denominator. This is going to be moved to the numerator, but I also want to factor those. So if you need to do two separate steps where you rewrite and then you factor, you can. I'm going to go ahead and combine steps. So hopefully it doesn't confuse you too much. So, and I'm going to drop down just a little bit. So I'm going to rewrite this fraction. I can pull out a 12, greatest common factor of 12, and I'm left behind with w minus 3. And here I'm going to pull out a 2, greatest common factor of 2, w plus 2. You could go ahead and simplify 2 over 12 if you really wanted to. I'm just going to wait. I'll probably end up doing that later. Alright, I'm going to change divide to multiply, and I'm going to flip this fraction. Flip this fraction. Alright, this goes to the denominator. So when I move that down to the denominator, I'm going to end up factoring out a greatest common factor of 3. So 3w minus 3, but it's in the denominator because I am moving it. Now here, this one's going to need just more than a greatest common factor. There is a greatest common factor of 4, but this is still factorable. So two things that multiply give you negative 4, add to give you 0. That's going to be W plus 2 and W minus 2. That's going to be what's going here. 4 W plus 2, W minus 2. Alright, so I have to look 3 places for restrictions. Oops. I have to look here, I have to look here, and I also have to look here. So I'm going to end up with 4 restrictions. So pretty much the only thing that you don't look for restrictions is the original numerator. So restricted values, W is not allowed to be -2. It's not allowed to be 3. Now, I already have a -2 for this one, so I don't have to state it again. So actually I only have 3 because I have a repeat. These two repeat. W is not allowed to be +2. Alright, now we can start canceling. So I've got W plus 2's that cancel, I've got W minus 3's that cancel, and then you can do 2 divided into 12 is 6. You can even cancel the 6 and the 3 and get 2. So it looks like I end up with 8 W minus 2. Or if you wanted to rewrite it as 8W minus 16, because technically that's a little bit shorter, where W is not allowed to be -2, 3, and 2. There's my answer. If you wanted to leave it like that, that's fine too. It felt a little awkward considering I didn't have any more parentheses in the denominator. So remember, you can change how you write things. That's all right. But those are your first dividing. Change division to multiplication, and you just kind of bump up the level of how many restrictions you have to do.